This is 2017 question 2 for relative velocity for applied maths. So for this question here for 2017, we'll start with question A. And A is talking about a girl cycling at a constant speed of 5 meters per second on level ground. When her velocity is 5j, the velocity of the wind appears to be 3ui and minus 4uj, where u is a positive constant. When the girl cycles with velocity of what we're given there, the velocity of the wind appears to be vi, where v is a positive constant. Find the magnitude and direction of the velocity of the wind. So this is very similar to question 2a from 2019. It is the wind appears to blow, so that's one of those questions where what we have to do is we have to resolve both the vectors, and from there then we're going to let either the i's equal the i's or the j's equal the j's to find what the velocity of the wind was, and from there we'll get the magnitude and velocity. So for this question here, the first piece of information we're going to be given is that a girl is cycles at constant speed of 5 meters on level ground when her velocity is 5j. So that's what I'm going to write down first, is that my velocity, the velocity of the girl, is going to be 5j. And I have that written here. So velocity of the girl is 5j. The velocity of the wind appears to be 3u I minus 4uj, and that's my velocity of the wind relative to the girl. So that's my first piece of information, and I'm going to use my velocity formula, and my velocity of the wind is equal to the velocity of the wind relative to the girl plus the velocity of the girl. So I'm substituting all my values in there. It's going to be 3ui minus 4uj plus 5j. And then I have my 3ui for my i's, and then 5 minus 4u for my j's. The second piece of information then up in the question says when the girl cycles with a velocity of minus 3i plus 4j, so that's the velocity of the girl, minus 3i plus 4j, the velocity of the wind appears to be vi, and again that's the velocity of the wind relative to the girl because it appears to her like that. Again, I'm using the same formula as I did in the previous part. The velocity of the wind is equal to the addition of the velocity of the wind relative to the girl and the velocity of the girl. So I end up with v minus 3i's plus 4j. I'm then going to either match my i's with my i's or my j's with my j's. Now when I go to match my i's with my i's, I can see that there's 2 letters there. So I'm going to take a look and see with the j's there's only 1 letter, so I'm going to use that one because I'll be able to find the u is equal to 1/4, which I have there. From there I'm going to sub that back into the velocity of the wind here. I only need to do it into 1 because both of those are the same thing. And when I substitute my quarter back into the velocity of the wind, I'm getting the velocity of the wind to be 3/4i plus 4j. All I'm doing from there then is I've drawn a little example of it over here in the corner as to where it would be. I know that it's going to have a magnitude of the square root of the first squared plus the second squared, and it's going to have a direction of the tan inverse of the j part over the I part, and that gives me 79.4 degrees. I've mapped that out to see where it is, and I can see that it is north of east, 74 degrees. There's my 74 degrees there, going north of east, and my magnitude is 4.0 meters per second. So that's the first part of that question A, complete for 2017. The second part then, part B of 2017, here we have a ship P is moving north at 15 kilometers per hour. A second ship Q is 10 kilometers west of P and appears to be moving relative to P in a direction east 60 degrees south at 15√3 kilometers per hour. I need to find the velocity of Q, and then I need to look at finding 2 minutes after the time when they are closest to each other. I need to find the angle of P, which is east theta degrees north of Q. And then I have my final third question. So let's look at the first question first of all. Now for these questions here, anytime they're talking about the closest or the shortest distance, that's using the shortest distance idea. You have to draw out your velocity of the ship P, the velocity of ship Q relative to P, and then the velocity of Q. And from there you're going to use triangles and only junior cert trigonometry to find then the information that they're asking for. So for the first one, it's asking me to find the velocity of Q. So the first thing I'm going to look at is the velocity of P. Now when I'm drawing out this diagram here, it tells me a second ship Q is 10 kilometers west of P. So for that information, the first thing I draw is I draw my Q and my P, and I draw my distance between them. And anytime they're talking about something like this, always do that. Always find the distance between those, or find a distance between them, and then you're going to draw the two of them as they are. We're then going to resolve the vectors and find the information that we're asked to find. So I have my Q and my P drawn. It's telling me that ship P is moving north 15 kilometers per hour. So that means that the velocity of P is just 15j, and it's a plus 15j because it's moving north. If it was coming from the north, it would be minus 15j. The next thing that I'm going to look at is Q, and it tells me that Q is going relative to P in the direction east 60 degrees south. So in this diagram here, my purple line is the velocity of Q relative to P, because it's relative to P in this direction. It's going east 60 degrees south. So east 60 degrees south. So if I look at that, that's the angle that I've marked in here, east 60 degrees south. And I've drawn in my purple line, it's going in this direction here. And then I know that it's going at a speed of 15√3 because they told me that in the question. So now I can find the velocity of Q relative to P by using my speed, which would be the U value. In this case, it's 15√3. So it's 15√3. Because I'm looking, if I change my colour of my pen there, because I'm looking for this part here, if I join this up, the J part of it is going to be, there's my opposite and my hypotenuse. So I'm going to use my sine, and it's going to be the speed by the sine of 60. So that's my J value. That's where I'm getting that over here. Whereas if I'm looking for the I value, that's this one here, and that's going to be the adjacent to the angle. So that's why I have to use cos. And that's where I'm getting my 15√3 cos of 60 with the I, and 15√3 sine of 60 with the J. Now I know that I'm going in the positive I direction because I am going east, but I'm going in the negative J direction because I'm going south. So that means that I know I have a plus for I and a minus for J. So now I have the velocity of P and the velocity of Q relative to P. I want to find the velocity of Q. And the way that I do that is the velocity of Q relative to P is always the velocity of Q minus the velocity of P. So I can move that around, and I can see that the velocity of Q is equal to the velocity of QP plus P. So all I've done there is brought that across, and it becomes a plus. And then I substitute all my information. My velocity of Q relative to P is going to be 15√3 cos of 60, which is 15√3 over 2I. And then the velocity of P is going to be 15√3 sine 60. And then don't forget about your 15J. And that adds to give me minus 45 over 2 plus 15, and that's J. So all I need to do is add those together to get me minus 15 over 2. I'm now getting the magnitude and the direction of that. So my magnitude is going to be the square root of the first squared and the second squared. The minus doesn't matter because you're squaring it, so it's going to go anyway. And I'm left with 15 kilometers per hour. That's my magnitude. My direction is always going to be the tan inverse of the J over the I. Oh, and we didn't need to find that. The velocity of it is fine, so that's all we had to do there. So just your velocity of 15 kilometers per hour. If it's a direction, you're using your tan inverse then. Okay. The final part, or the second part of this question here, it said 2 minutes after the time when P and Q are closest to each other, P is east degree, a certain amount of degrees north of Q, find that value of the angle. So what I'm going to have to do here is I'm going to use my previous diagram, and I know that I have the purple line on this diagram is the velocity of P relative to Q. I know that the 10 kilometers is a distance that I was given where they were at a certain stage. And I know that now in the eyes of P, P is not moving, but Q is moving along that line, that purple line going kind of southwards. The closest distance is that green line with the 90 degrees, because it's always going to be, the shortest distance is always going to be at a 90-degree angle. So all I'm doing then to find that angle is, if I move down to my part 2, I'm going to use this triangle here to find what that green line is. And when I do that, I have my 10 and my 60 and my opposite angle, and I'm going to use my sine of my 60 equals opposite over 10. So that's going to be 10 sine 60. That's 5√3. So that's where that 5√3 is coming from. So the next thing I have to do then is coming down here. I've done that part 1. I've now redrawn this over here just so we can see it as well. That's kind of a more kind of basic version of it. I have found this thing here. That's my 5√3. The second thing I need to find then is in my question, it told me it was 2 minutes after that. So if I'm looking for 2 minutes after that, then I'm not looking for this stage here. I'm looking for 2 minutes later. So that means that I know I'm going, or the velocity of Q is going 15√3 in this direction. So what I'm going to do with that 15√3 is I'm going to multiply it by 2/60 because this is in kilometers per hour. So I need to change my 2 minutes to be in kilometers or into hours. And I know that that is a distance of √3/2. So that's how far the ship Q goes in 2 minutes. So I know that that is this distance here. Okay, that is √3/2. The third thing I'm going to do then is I'm going to find this inner angle here. Now that I have this line here and I have this line here, I'm going to just use my sine, cos and tan from when I was doing junior cert, and I'm going to go tan of my angle equals the opposite over the adjacent. And again, I found both of those sides earlier. From there then I'm going to go tan inverse and I'm getting 84.3 degrees. So all I've done there in those 3 steps is I have found my shortest distance. I have then used the fact that I know the speed of this line here, and I know how far or how long I've gone, which is 2 minutes, to find what this distance was here, and it was √3/2. And I've used both of those to find that angle there of 84.3. So now that I have that, I need to again go back and take a look at my question and see what they were asking me to find. They were asking me to find when P and Q are closest to each other. P is how many degrees east, something degrees north of Q. So I'm looking now at Q and how am I going to get to P from where Q is now. So what I have to look at from here is that if this is 84.3 degrees and this is 60 degrees, then this is also going to be 60 degrees. Because they're talking about east a certain degrees north, I have to look for this angle here. And when I look for that angle there, I can see this is a straight line, so I'm going to take it away from 180. And when I do that, I'm left with 35.7. So that is that angle there of 35.7, and that is where from Q it is north of east 35.7 degrees. And that is my second part of that question. My third part of that question then, it says if Q can be seen for 12 minutes, from P for 12 minutes, find the distance between P and Q at the end of this time. So what they're looking for here, if I just use this diagram here, it's saying, well, at this stage here, that's when they're closest together. They're able to see each other for 12 minutes. So that means that for 6 minutes going out this side and 6 minutes going out this side, they are visible. So what they're looking for is they're looking to find the distance between Q and P at the end of this time. So they want to find this distance here between Q and P when they're still visible, but just before they're stop being visible. So that's the length of that line is what I'm looking for when I know that this is 6 minutes. So that's the aim there. So now I'm going to go back down to my question. I've drawn out, again, here's my question, there's my 10 kilometers. There's my velocity of P relative to Q. I'm going to make that look a little bit tidier. And what I'm going to do here for this one is I know that I have 5√3 is this here. I know that I'm going a speed of 15√3 kilometers per hour. I know that it's going to take me 6 minutes to get to this point. So I'm going to find that length there because then I can just use Pythagoras to find this x value here. So I'm going to get 15√3, I'm going to multiply it by 6 out of 60 because again this has to be out of hours, and I'm getting 3√3/2. So that is the distance of this purple part here. So now that I have that purple part, I also have this length here of 5√3. I'm going to just use Pythagoras' theorem to find this x value, and when I do that I got 9.04 kilometers. And that's that question completed.